methods to solve a system of linear equations is called elimination. To use this method, both equations must be in standard form. Remember, an equation is in standard form if both the variables are on the same side of the equal sign. That is, ax plus by equals c. To demonstrate the steps to solve by elimination, I'm going to use the example 7y plus 5x equals 18.9 and 2x minus 3y equals negative 8.1. The variables for each of these equations are on the same side of the equal sign, so we're able to move on with the process. The first step of elimination is to write the system with the variables and constants lined up. It's common practice to write the x term first, followed by the y. So I am going to rewrite the first equation as 5x plus 7y equals 18.9. Then I'll write the second equation lining up the variables and the constants. So under the 5x, I'm going to put a 2x. Under the 7y, I'm going to put a negative 3y. And under the 18.9, I've got a negative 8.1. Now that we've got them lined up, the next step is to check each variable for opposites. An opposite is one that has the same number but the opposite sign. For example, the opposite of 5x is a negative 5x. If there is no opposite, you transform one or both equations by multiplying all parts by a factor that will create an opposite. Looking at our example, 5x plus 7y equals 18.9 and 2x minus 3y equals negative 8.1. There's no opposites when you look at the variables, so we're going to have to create one. The easiest way to create an opposite is to look at the coefficients for the variables, and I usually go with the smallest coefficient just so I don't have to work with such large numbers. What I'm going to do is I'm going to multiply the first equation by a negative 2. That 2 is coming from the x term of the second equation. And I'm going to multiply the 5 by the other equation. Again, that came from the first equation. And I did the negative with the 2 just so I know I'll be creating an opposite sign here. So once I've multiplied all that through, I now have negative 10x minus 14y equals a negative 37.8. And 10x minus 15y equals negative 40.5. Our x's are opposites. They're both the same number but different signs. So now I'm going to just draw a line under the equations and add the parts together. After adding the two transformed equations together, I've got one equation with one variable, which brings me to step 3. That is to solve the resulting equation for the remaining variable. I had negative 29y equals negative 78.3. Dividing both sides by negative 29 gives me that y is equal to 2.7. Now that the value of that variable is found, step 4 is to substitute it into one of the original equations and solve for the other variable. When I substitute 2.7 in for y of the first equation, I get 5x plus 7 times 2.7 equals 18.9. Using the distributive property to simplify the left side of the equation gives us 5x plus 18.9 equals 18.9. Subtracting 18.9 from both sides gives me 5x equals 0. Divide both sides by 5, and I've got that x is equal to 0. Now that we have a value for both variables, I'm going to write the solution as an ordered pair, and that would be of the form x, y. And then I'll check for reasonableness. Our solution as an ordered pair is 0, 2.7. To check for reasonableness, I'm just going to take that ordered pair and put it back into the original equations. The first equation becomes 7 times 2.7 plus 5 times 0 equals 18.9. You could type that into a calculator or perform the operations by hand and show that the solutions do satisfy the equation. The second equation becomes 2 times 0 minus 3 times 2.7 equals a negative 8.1. Again, working that out shows that the solutions we found do satisfy the solution. So we can conclude that the point 0, 2.7 is a reasonable solution.